Here's a quick review of transformations of functions. I'm going to start with just going through the functions on this video and what the transformations look like. And then I'm going to make another video where I actually show you those transformations on different graphs, and then you can practice some. So transformations, you always have to start with a parent function, with something that has nothing done to it. So in this case, our parent function is going to be f of x equals x squared. So it gives us just this nice simple parabola to work with. But it could be a cube function, a trigonometric function, any function that has nothing done to it yet. And that's what we use as our parent function. So we have three basic types of transformations. Our first one is translations. This is when we just move the graph around, but we do not change the shape of it at all. So we can move our graph up and down by adding a constant to that y value. So this is when we're outside the function and I'm taking all of my y values and I'm adding a new value to it. So that makes my graph move up because all of my y values are now bigger. If I want to move my graph down, I need to take values away from those y points so that I get a graph that has been moved down. So I would need to subtract a value. So if my c is positive, I'm going to move up. If my c is negative, I am going to move down. When dealing with horizontal translations, moving left or right, this is where it gets a little bit tricky. If I add a value inside my function, so you can see I'm now inside that squared, I actually move towards the negative. So this is kind of counterintuitive. You would think, oh, I'm adding to my x, I need to move to the right. But the inside lies. When you see that positive on the inside, it actually causes your graph to move to the left. So we worked with this on that homework, the transformations of functions. So if you need to review that, you can see why this causes the graph to move to the left. If I want to move to the right, I actually need to subtract a value away to make it move to that positive side. The second transformation is a stretch or compress. So this is where we start changing the shape of the graph. So we can stretch or compress in the y direction by multiplying the entire function by something. So you can see I have the function x squared and I'm multiplying it by 0.35. So this causes my graph to compress. If I wanted to stretch it, I would need to make c bigger than 1 so that it causes the graph to move in the other direction. When I stretch or compress in the x direction, we have that same issue of the inside lying to us. So even though it looks like I'm multiplying by 2, I'm actually taking my function and causing it to be half my x values. What that 2 does is it causes our x values to happen twice as fast. So instead of my x value of 2, where my point used to be, it moves to that x value of 1. Because my graph is happening twice as fast, it looks half the size. So when you see a 2 here, you're actually multiplying everything by a half. If you saw a half there, you needed to multiply everything by 2. So it causes that reciprocal function to show up again. So just know that inside again is lying to us. If I see a 2, you're thinking in your head 1/2. The last transformation that we have is the reflection. If I want to reflect over the x-axis, turn my graph upside down, I need my negative to apply to the entire function. So again, I'm outside the x squared, and it's causing my graph to flip upside down. If I wanted to flip over the y-axis and flip left and right, I need to multiply inside the function. So when I multiply inside the function, it causes that reflection left and right. Of course, in an x squared graph, that doesn't actually do anything to our graph, because if I square a negative, it just becomes positive. So we can see here this example of the square root. I've taken my original graph and I flipped it over the y-axis. So I caused that reflection over the y.